So this is one of the first projects I've ever done on Perfboard. This is a DMX control module for a Coemar Venus, which is a really old piece of disco lighting that kind of predates DMX. Maybe it doesn't predate it, but it certainly doesn't have DMX control. So this is kind of meant to interface. It basically sits in place of the manual switches that let you, and it controls the motors because the light's always on. So there are 4 motors on the device, 3 of which you can turn on in 2 directions, and the last one you kind of just turn on and off. And so basically the DMX signal, you're presented with 4 DMX controls, and they're all the way down is off for safety purposes, but the 3 that can go both directions, the middle is off, and then up is this way, and then down is the other way, and then all the way down is off again. And then for the 4th one, it's just off, on. This is my first time really working with Perfboard for something serious. I found out one of the most annoying things about Perfboard is when you want to put jacks into it. Jacks don't often have the right spacing, and drilling new holes in Perfboard is not as easy as you'd think, because the drill bit, even if you're using a drill press, will often want to go into one of the holes that's already there. So you can see I tore the hell out of this before I finally got the XLR connectors, and you can see I did this kind of little hack job where I hold this down with a wire, but these are actually pretty sturdily in there. These are 3-pin, and then I was going to have a 5-pin mounted remotely and connected with a wire, but so the basic circuit here, ATmega 328, because I've got like a billion of them. The out header here is plus 5 volts, ground, reset, and these 1, 2, 3, 4, 5, 6 are the 3 bidirectional motors, and then the unidirectional motors is one of these 2 down here, I don't remember. I was initially programming it with Arduino ISP, but that kind of fell apart, so I kind of, as an afterthought, installed a real ICSP header here, and the main kind of feature here, so these dip switches connect to these pins here and set the base address for the DMX control. And the kind of feature of this is that one of the specs that was given to me was it has to be isolated. It has to be, the DMX has to be completely isolated from the power of the device itself. And so the way I achieved this is with this isolating DC-DC converter. This is the it's just 5 volts to 5 volts. You give it plus minus 5 volts in, it gives you plus minus 5 volts out. It's actually not very well regulated in that it usually gives you closer to 6 volts, but the only thing it's powering is this RS485 transceiver, which can tolerate the 6 volts, so not a big deal. The transceiver's only being used to receive. We're not transmitting DMX here. And then the incoming differential signal gets turned into a regular single-ended signal, which then goes through this optocoupler. I think it's a 6N. What is it? 6N137. And then the output of the optocoupler goes into the UART pin on the microcontroller. It actually works, surprisingly well. Oh, and there's a jumper here to disconnect the DC-DC converter from the power, so when you're programming it, you're not powering this thing. So I had my friend Dave cut isolation all the way through, although as you can see it's not finished, still need to cut through there. And the only things bridging it are this and that. Yeah, it's been an interesting project. This is actually Eurocard strip board. It's a bit messier than I thought. I've become a master at cutting traces with a utility knife, and then soldering them back together when it turns out that I made a mistake. I actually found that the biggest pain is that these tarnish after a while, and it's not just enough to flux them. You actually have to abrade them a little bit to get the solder to stick to it. But the code, I don't know if I posted the code on GitHub, but it's really, really simple code. I'm sure there are a billion examples out there. But yeah, it was a fun project.